to prove that the drug is effective on humans. Tests on humans using very small quantities of the drug, the first stage in the clinical trial of the drug, and then finally tests on animals used to find if the drug is toxic. So this question then looks at talking about caffeine, daily dose in development of human Alzheimer's in human. If you read through the paragraph then, it doesn't actually talk anything really about humans. It's more about testing on mice and looking at their caffeine dose. So the headline for the passage is not justified. Explain why as fully as possible. Trial was too short. I think they only gave them to them for a couple of days. And it wasn't even humans. Investigation was not repeated. Mice not the same as humans, which is a large thing. We test on mice an awful lot, but they're nowhere near the same biochemistry as humans. So what responses they have will not be the same as what we would have. And it also improved their memory loss, but didn't delay it, which is the problem with Alzheimer's, is that you are eventually going to get memory loss. This question then, graph shows the number of people with measles in the UK between 1940 and 2010. Compare how effective introducing the measles vaccine was with introducing the MMR vaccine. So you can see here's the measles introduction, here's the MMR. Use data from the graph. So both lead to a reduction. So you can see here, it's up here, and it's when both of them are introduced, it does actually show a rapid decrease. Measles vaccine caused a large drop. MMR wipes out the measles. If you see here, by the 2000s, there were no cases of measles. The MMR vaccine was introduced in 1988. Other than the measles, with two other diseases, does MMR vaccine protect against mumps and rubella. So, to immunise someone against measles, a small quantity of the inactive measles pathogen is injected into the body. Describe what happens in the body after immunisation to stop the person catching measles. White blood cells produce antibodies, rapid response, so memory cells are made. Memory cells, make sure you write that in your books. Memory cells, if re-injected. Scientists at a drug company developed a new painkiller drug called Drug X. Painkillers do not cure infected disease. So I did write originally their purpose is to block pain receptors. But when I went back and looked at the mark scheme, that isn't what the answer was looking for. Why do they not cure infectious diseases? They don't kill pathogens. That's not actually their function in your body. Again, another drug trial chose 600 volunteers, so quite large, but not as large as some of the other ones that we've looked at in this past paper booklet, talking about different drugs that each person was given. Over the next 7 hours, the volunteers recorded how much pain they felt. To get valid results, the group of volunteers should be matched for as many factors as possible. Suggest 2 factors that should be matched. So I picked age, gender, whether they have any pre-existing health conditions. You could go really rogue with that, but I keep it quite simple. Then they showed you results and how many times they saw pain or how much pain was decreased and over how long they took the drug. So how many volunteers did feel pain 4 hours after taking drug X? So drug A, So at 4 hours, 25% of them had seen a decrease. So that meant that out of 100, 75 of them, or 75%, still were feeling pain. Give one advantage of drug A, but not drug B, is a quicker reaction. So a quicker pain decrease. Give 2 advantages of drug B, but not drug A, longer lasting over a period and a higher decrease in pain. So if you can see, it's got a higher line. Drug X is more expensive than both A and B. The pharmacist advised the customer that it would be good to just take drug A and B instead of drug X. Do you agree with the pharmacist's answer? Yes. Rapid pain relief and then longer lasting, cost less, the sum of A and B is greater. Drugs may cause harm to the human body. A drug formaldehyde was developed in the 1950s. What was the drug formaldehyde originally developed for? It was a sleeping pill to look at people who had insomnia. Soon after it was developed, formaldehyde was found to be useful for treating another condition, morning sickness. Describe one harmful effect of formaldehyde. It was unborn babies were born, so it wasn't the mothers, the expecting mothers who developed limb defects. It was the unborn babies who did. suggests why the harmful effect has not been detected during clinical trials. The reason was that formaldehyde was used to develop as an insomnia. So they trialled it with people who had insomnia, collected results. It was then not trialled on pregnant women or any like computer tests on people who were pregnant. As horrible as it sounds, it wasn't done on mice that were pregnant. So they had no trials on pregnant women. Using recreational drugs may cause a person to become dependent on a drug. What happens to the body to make someone dependent on a drug? Changes to the chemical process within the body. Again, another graph. I think you're starting to notice that with this topic, the largest thing that they can give you is a graph and ask you to look at the data. So doctors rated different recreational drugs depending on how dependent users become on them. The graph below shows the results. It is illegal against the law to take class A, B or C drugs. Unclassified drugs are legal. Some people think that some legal drugs should be made illegal. What evidence is there in the graph to support this view? There is more dependency on something like nicotine and alcohol than there is on steroids, GHB, even cannabis, ecstasy. So there's a higher dependency on legal drugs. Alcohol is higher or twice as high as LSD and ecstasy, which are class A drugs. Suggest one other piece of information about legal drugs that would need to be considered before classification of these drugs was changed: the harmfulness. So do they actually have the same effect as ecstasy on your body?